Hello and welcome to this lesson about problem solving number riddles. The learning target for this video is setting up equations to solve number riddles. So first of all, I want to talk about a couple different types of number riddles you tend to see and then the process. So the first type of number riddles you'll see is usually the sum slash difference, depending on the type of the problem, difference of two numbers. And you'll have to find both of them. But you're going to be given information only about one. Actually, and you won't be given either one explicitly. The second one is consecutive integer problems. Now, what's neat is that the process for both of these can be solved there we go, by using what I like to call a placeholder. So I know it seems kind of crude, but that right there is what you're going to use to solve this, because the way these problems work is it is something plus or minus, depending on the context, something else is equal to something. And so if you set up the placeholder, you're going to help yourself set up an equation that will help you solve this problem. So for example, let's take a look at sum or difference of two numbers. And so here's what I'm talking about. You're going to be told something like the sum of two numbers is 43. Find both numbers if the larger is 4 more than 12 times the smaller. So here is how this works. We use our placeholders. So we have two numbers, number 1, number 2. And we're going to set them equal to this number right here, 43. Now, here's the catch. We have to do a little bit of reading and interpreting here. Find both numbers if the larger is 4 more than 12 times the smaller. So here's the thing. We don't know anything about the smaller number. So what we're going to do is we're going to let the smaller number be x. Okay? And then that means that the larger number is going to be this expression of x. 4 more than 12 times the smaller. 12x plus 4. Now I've found my two numbers. I put them in here. X, 12x plus 4. Now here's the mistake a lot of students make. They just do the 12x plus 4. Because they read the expression and they know it's got to equal 43 and they totally leave off that x. And that skews your answer incredibly. So make sure you do not forget that. Now at this point I'm going to erase that 1 and 2 so that way we don't confuse it with fractions. They're not fractions, that was a placeholder. So we now combine like terms. X plus 12x is 13x plus 4 equals 43. Subtract 4 from both sides. 13x is equal to 39. Divide by 13. X equals 3. So what that means is that 3 is the answer to x. That is the smaller number. To find the other number, we have several options. We could either subtract from here, or we could plug it in right there. So pick your poison, if you will. Right here, I see 43 and 3. I'm just going to do a quick subtraction. The other number has to be 40. So the two numbers are 3 and 40. So again, make sure with word problems that you're actually answering the question that's given to you. Another variation of this is find the larger number, find the smaller number. So just make sure that, you actually answered the question that was brought forth here. All right, let's see what's going on. This is being weird. Okay, there we go. I fixed it. All right, now let's read this one. The difference of two numbers is 19. Find both numbers if the larger is 1 more than 3 times the smaller. Right, so now this is where we need to be extra careful. First of all, we have difference. So we'll use our placeholders. One number minus another number equals 19. Now that we're dealing with subtraction, we have to put on our thinking cap just a little bit more. 19 is the answer. Well, I have two numbers, and they're not the same. If they're the same number, the result would be 0, but it's 19. So what this means is that I have a large number minus a smaller number. If it was the other way around, it would be negative, right? So what that means is I have to think, all right, the larger one is 1 more than 3 times the smaller. I still don't know anything about the smaller number. So that's going to be x. So I'll put x there. The larger one, though, is this expression, 3x plus 1. 1 more than 3 times the smaller. You have to make sure I put it on the left-hand side. Again, a mistake some students are going to make is they're going to write it as x minus 3x plus 1. And they may or may not include parentheses there. Got to be careful. You do that, you're going to get a wrong answer. So make sure you set it up correctly. We have now, and now combine like terms. 3x minus x, that is 2x plus 1, equals 19. Subtract 1 from both sides. 2x equals 18. Divide by 2. X equals 9. And that's this number right here. So I got to figure out what this number is, and 2 options, can plug it in. So this time let's do that. We'll get 3 times 9 plus 1. That's 27 plus 1, which is 28. And the 2 numbers are 9 and 28. Now let's take a look at consecutive integer word problems. Now consecutive integers, these are numbers that go in a progression. So 1, 2, 3. Those are consecutive integers. Now, we have a line in the sand when it comes to these types of problems. We have regular consecutive integers, and then we have even or odd consecutive integers. And what's weird is even and odd are grouped together. Now, with regular consecutive integers, you're just going up each time. So we're going from 1 to 2, 2 to 3, you increase by 1. And the same is true if we're looking at something like negative 25, negative 24, negative 23. Each time we're going up by 1. So algebraically, if we don't know where we are, the first one is x, the next one is x plus 1, and the one after that is x plus 2. Think about how you get from 1 to 3. You have to add 2. And so that's why if our first one is x, the next one is x, or the third one is x plus 2, and we follow that pattern if needed. For even or odd, we're now thinking of stuff like 2, 4, 6, or 3, 5, 7. Now take a second and look at the difference between the two numbers. Or sorry, not between the two numbers, but between all the numbers. Each time we're increasing 2. And it doesn't matter if it's even or odd. We increase by 2. So algebraically, the first one is still x, but the next one is x plus 2. And the one after that is x plus 4. And just take a look at going from 2 to 6. You have to add 4. To go from 3 to 7, you have to add 4. So that's the pattern you need. Now that we have that, we continue to use our place setters to solve these problems. So let's look at the first one. The sum of 3 consecutive integers is 21. Well, placeholders. I have 3 numbers that I'm adding together, and it's equal to 21. Since it's regular consecutive integers, x, x plus 1, x plus 2. At this point, I combine like terms, so I have 1, 2, 3 x's, and then 1 plus 2 is 3. That equals 21. Subtract 3, 3x equals 18. Divide by 3, x equals 6. Now I'm not done, because I've just found what x equals. I need to find the integers. Well, I start at 6, and then I add 1, and then I add 2. And those are my integers. Now, let's take a look at this example. Find 3 consecutive odd integers. So I'm still adding 3 numbers. So I'll set up those placeholders. I set it equal to negative 45. Seems a little weird, but it could work out. And my first one's still x. But now, the next one is going to be x plus 2. Guess what? It doesn't matter that it's odd. The mistake a lot of students will make is they say x plus 1 and x plus 3. That's not how you do this. That's not consecutive even integers or odd integers. So x plus 2, x plus 4. If you see even or odd, this is the pattern you follow. And then you repeat. So combine like terms, 3x, 2 plus 4 is 6. That equals negative 45. 5. Now here we're going to subtract 6 from both sides, so 3x equals negative 51. Divide both sides by 3, x equals negative 17. And then we end up getting, so that, again, that's what x equals, but we need the integers, so negative 17. Now with negative ones, make sure you're going the right direction. We're going to the right. Negative 15, negative 13. Box it, walk away. One more example for good measure. The sum of 4 consecutive integers is 20. Find the integers. So this just goes to show, there's other ways we can kind of cook up these problems. 4 numbers and they're even. So 1, 2, 3, 4. And that equals 20. First one, x. Since we're talking even, x plus 2, x plus 4, and then x plus 6. Just keep adding 2 to this number right here. Now combine my like terms. I have 1, 2, 3, 4 x's. And I combine my numbers. I get, let's see here, 4 plus 6 is 10, plus 2 is 12. That equals 20. 4x is equal to 8 now. And x equals 2. Again, that's what x equals, but I need to find the integers. So it's 2, add 2 more to get 4, add 4 to 2 to get 6, and then add 6 to 2 to get 8. Or just to go up by 2 each time. Either way you want to think about it works. And so that's how we do consecutive integer problems, whether it's regular, even, or odd. So let's just recap everything. The big thing is set up the equation. And you do that by using placeholders. Placeholders help you organize all your pieces. But there's a warning, you still need to use critical thinking. So keep in mind, if we're talking about the sum of two numbers versus the difference of two numbers, the sum, it doesn't matter how we set those up. But the difference, it does matter. So make sure you think about which one's on the left, which one is on the right. So good luck with your homework or practice, and let me know if you have any questions.